Okay, in sac112 number 4, we've got a horse pulling a sleigh. I called in a special artist to depict this, somebody that's very good at drawing horses. Here's our sketch, and now we got to draw a free body diagram. They're asking us to draw a free body diagram of the horse. Alright, let's take a look at this horse. It's going to be the earth pulling on it. We'll call that the weight force, acting in the downward direction. I'll use the symbol W to represent that. The ground is going to be pushing up on the feet, creating a total normal force. Some on each foot. I'm just going to represent that by one total normal force. Call it N in the upward direction. Okay, now where that horse is tied, fastened to the sleigh, there's going to be, it's actually the rope is going to be pulling on the horse. So I'll go ahead and draw the force of the rope on the horse. Call it S sub R. The horse is pulling forward on the sleigh, so there would be a forward force of that same magnitude actually on the rope, and then the rope is touching the sleigh. So the rope is pulling forward on the sleigh, so there'd be a forward force of that same exact magnitude acting on the sleigh. But we're asked to draw a free body diagram of the horse, so we only include the forces acting on the horse. Okay, now there's one more. This horse, in pulling the sleigh forward, is going to be pushing the ground backward. In fact, if there's some pebbles on the ground there, you'll actually see him move backward. And in response to that, the ground is going to be pushing forward on the horse. That's referred to as a reaction force, or I'm going to call it lowercase f for the frictional force. Assuming, for instance, the horse is walking on asphalt, a regular street, the horse is pushing backward on the road surface pushing forward on the horse's hooves, in such a manner that there is no sliding, and hence we're actually dealing with a static friction. Even though the horse keeps on picking the feet up and putting it back down while that frictional force is acting, it's a static frictional force. Okay, we've got everything that's touching the horse. The road took care of both the normal force and the static frictional force. The rope, got that covered. And then the weight force exerted on the horse by the earth, a force exerted by an object on the horse that's not touching the horse. So the earth not touching the horse, but using that gravitational force to pull downward on the horse. So we got everything that's touching it, plus we got that one force that acts on the horse without touching it. I'd say this is our final answer. This is the free body diagram for the horse. If there is some acceleration, I could put that on there. We're just told that the horse is pulling the sleigh, so we don't know whether there's any acceleration or not. Could conceivably be 0.